Good morning, Year 11th. I hope you're sitting down comfortably and you have your notebook out ready to take notes. The idea is you copy down the notes, you bring the notes to the next class, and then we do work and practice during the class. This hopefully should not take too long. The skill I want to teach you is one that you should have seen in Year 10. It's called completing the square. Now, it's used to solve quadratics. It is not elegant, it's not easy, but it always works. What we've seen previously with null factor law and factorizing is very elegant, almost cute, but it doesn't always work. So this one always works, but it's not easy. And generally, I would give you the advice of try factorizing. If factorizing fails, this is a good plan B, or the quadratic formula. But completing the square first. All right, so let's start with this one. Now, this here is the type of quadratic that we can, what we call, solve by directly. Solve directly is when you can see an x and you just pull everything else away from it until you've got the x left over. So let's do that. I have to lay my screen flat, so you're going to see the ceiling. Enjoy. If I was going to pull this apart, I would divide both sides by 2, divide by 2. And I assume you're getting this down in your notes. What you have left then is x plus 5 squared equals 5. Don't like that pen. Right, then we need to get rid of this squared. So what we're going to do is we're going to square root both sides. When we square root both sides, we have to do plus or minus. So remember, if we had, for example, a squared equals 9, a equals plus or minus 3. That square root in this step has to be accompanied by a plus or minus. So when we do it over here, we're left with x plus 5 equals plus or minus the square root of 5. Now, the fact square root of 5 isn't nice, shouldn't bother us too much. We're okay with the square root of 5. Then we get x on its own for the final step. X is equal to negative 5 plus or minus root 5. So on this step, we're just taking 5. So yeah, it's 5. All right, so our two results are really minus 5 plus root 5 and minus 5 minus root 5. They're ugly, but they're surds, and we've done some work with them, so we can just leave it like that as the two values for x. All right. The reason this works so well is because we had a single x, and sure, it was wrapped up with a squared and it had a 2 in front and so on, but a single x, and we can solve it directly. So completing the square is about manipulating the formula to get that single x. So how do we do it? All right, first of all, you need an x squared at the start. So that needs to be just a 1. What we do is we divide everything by 3. Now it works out quite nicely on this side. This becomes x squared, this becomes plus 2x. This here becomes 2 on 3. And that's not particularly nice, but just leave it as a fraction. Don't be tempted to go to decimals. There is a good place to go. Right. Then we want to set up a perfect square. So a perfect square is the form a plus b squared, which is a squared plus 2ab plus b squared. And what we do is we basically take this center number here, halve it, and then that gives us 1, and we square it, which is 1. Take the center number, or the coefficient of x, halve it, square it, and add it on. So what that looks like is x squared plus 2x plus 1 equals 2 on 3 plus 1. Whatever you do to one side, you must do to the other. So keep it balanced in that respect. Then what we've set up here is a perfect square. I need more space. That factorizes into x plus 1 squared. If you need to convince yourself you're looking for two numbers that add to 2 and multiply to 1, that's 1 and 1, so it's x plus 1 all squared. On this side here, combine the fractions. That should be 5 on 3. If you're not convinced of how that works, 2 on 3 plus 1 on 1. Now really, we want that 1 to be something we can work with. So I'm going to rewrite it as 3 on 3. That becomes 5 on 3. Alright, then from here we solve directly. Square root both sides. X plus 1 equals the square root of, or plus or minus the square root of 5 on 3. X equals minus 1 plus or minus the square root of 5 on 3. And you're done. There are your two solutions for X. Now, it's not always going to be nice. Often you're going to throw fractions. Sometimes there'll be fractions in this part as well. But the idea is to basically soldier on. Alright, last example. I've included this. That's the relevant part of the textbook, if you want, but you don't have to write that down. Alright, last example. Please do copy this. Alright, we don't like the fraction, so we ditch the fraction. And we ditch the fraction by multiplying both sides by x. Giving us 3x squared minus 2 equals 4x. We want all the x's on one side, all the numbers on the other. So I'm going to take 4x from both sides and add 2, both in one step. 3x squared, take 4x, equals 2. Alright, here's the slightly nasty thing. We need to get the coefficient on its own. So we need the leading coefficient to be 1. So, and this is nasty, I'm going to divide both sides by 3. And you're like, but 3 doesn't go into lots of stuff. You're right, it doesn't, it's not going to be pretty. 3x squared divided by 3 is x squared. That's what we want and need. Then we have minus 4x on 3. And then we have 2 on 3. Alright, it's a bit ugly, but it's still going to work. So what do we do now? Well, we take this term, minus 4 on 3, we halve it, so divide by 2, and square it. Now this you need to know how to do without using your calculator. So treat this as an opportunity to practice fractions. Minus 4 on 3 divided by 2 is the same as multiplying it by a half, so it's minus 4 on 6, or you probably prefer to write it as minus 2 on 3. Bearing in mind that the whole thing is still being squared, so the whole thing is really 4 on 9. Coefficient, halved, squared, then add that on. So, x squared, take 4x on 3, plus 4 on 9, equals 2 on 3, plus 4 on 9. Whatever you do to one side of the equation, you also do to the other. Now, this here is a perfect square, but it looks like a funny one. It's a perfect square using this part here, and it will always use that part. You can see up above, that 1 is what we added on and took off, and that 1 was what went in the brackets. Here, the half portion, the minus 2 on 3, is what goes in the brackets. So we can write this as x take 2 over 3 squared. Now, you can expand out using FOIL and convince yourself that this is in fact the same as that. It's not pretty, but it is the same. And this is then equal to these two added together. That's going to be 6, 10, 10 on 9. If you're not sure about that, then that's okay. We're going to practice lots and lots of fractions over the next couple of weeks. Square root both sides. X take 2 on 3 equals plus or minus the square root of 10 on 9. X equals 2 over 3 plus or minus, because I'm adding 2 on 3 to both sides. Now that root applies to both the top and the bottom. So root 10 is about as far as we can go there, over 3. And you'll find more often than not, these are the same. Not that that's super important at this stage, but that is our answer. Note that it looks eerily like it came from the quadratic formula. That's kind of it did. The quadratic formula will give you the answer of 2 plus or minus root 10 on 3. But it's the same answer, which is cool. So next lesson we're going to learn a quadratic formula. This lesson, completing the square. The process is, get it, so there's a constant on one side, coefficient is 1 of x squared over here. Then whatever that middle term is, target it, pull it aside, halve it, square it. Add that bit on, add it on the other side. Whatever it was halved goes in here. Solve from there. It takes practice. Don't stress it now if it doesn't make 100% sense. Just bring the notes to class and we'll practice off the notes in class. Thank you very much.